So by now, you're probably getting used to the way Python operates. And after having completed several activities, let's take a moment to review what's happening with Python, because all computer programs do the exact same thing, and that is to read input, process the data, and to write the output. And even those programs that don't use REPL modes will allow us to create functions that are going to do the same thing. In other words, take input, process data, and write output. The fun thing to note about Python is that we have the ability to make one program's output become another program's input, so we can exchange data back and forth, not only using Python, but by reading someone's standard output as part of our standard input and allowing another program to read our output as part of their standard input. Known as application chaining, all programs that I'm aware of will allow us to hook things together in this way. And if you want to learn more about application chaining, take a look at my Python 3000 opportunity that will allow us to hook things together using many different programming languages. So once again, to review what we've seen, we now know that computers love to compile things down to numbers, whereas humans like strings. And in Python, the difference between our script files or even our REPL mode sessions is the fact that somebody is taking what we write line by line to compile it over into a computer program. And that's why we either need a compiler or an interpreter so as to interpret or run our computer program. So while I like to note that we do indeed like to use integrated development environments, all an IDE is doing is taking our input and looking at the output so as to integrate what we write into what Python writes. And in addition to Python, of course, we have ways of producing documentation from our scripts known as PyDoc. And if you want to know more about how to document your programs, creating first-class functions that can be accessed by the help system, go ahead and take a look at one of my Python 1000 or 2000 educational opportunities. Well, now that we know how handy it can be to put our statements into scripting files so as to rerun the scripts, we should take a look at how we can use functions and blocks so as to allow us to group things into blocks of statements for us to reuse. Using a def keyword, of course, we can create a function, and much like input, we can either have parameters or not. And if we don't have parameters, of course, for the input function, it's always nice to provide a string so people know what we're expecting them to do. And because input always returns a string, we know that we can use the strings is our num function, so as to see if every character in the string is alphanumeric. Lots of things going on here. The first, of course, is we're going to be defining a function and then inputting an indentation of white spaces. And in Python, whenever we start a block, those white spaces even have to be spaces or tab characters, but they really can't be both. And the best thing to do when using an IDE is to simply go to the end, in this case to the colon after read input, and push the enter key and let the tabbing automatically take place for us. But of course, if we're using VI or Notepad or any one of the ASCII editors, keeping our tabs aligned can be pretty difficult. After our definition, of course, you notice in a whole new block, we're going to simply create a variable, a very Pythonic TRF, a little wordy though in my opinion, so as to read input. And just like the regular input, our read input will take the parentheses so as to call the read input function. Ultimately, of course, we have something on the left, or the TRF, which is usually called a L value, being assigned to something on the right, which, not surprisingly, we call an R value, so as to allow us to receive either a true or a false, as our is-elnum will return to us. So just like print and other functions, we can also have a default parameter. And in this case, we're going to have a default prompt, please enter, that we'll always use if none is provided before performing the exact same operation. Now, from time to time in modern Python, you will see something we call type hinting. And as we see here, we're hinting that input is going to be the type of string by using the colon, and its return type will be Boolean. And the reason why we call it type hinting is because we can still input anything as our prompt, for example, an integer or a Boolean, and return anything from our function, for example, a string or any other complex or simple type. So type hinting is just that. Type hinting is a way to help document the suggested types and the expected types that can be used to manage the input and output of our functional blocks. So blocks help us organize code, but one thing blocks have in common is a gatekeeper. And as we've seen on read input, the name of the function becomes our gatekeeper. That must be called before entering it into the sub block. But in Python, we have other constructs which nest blocks underneath them. And although we won't be talking much about classes in this educational opportunity, the Python 2000 Beyond the Basics opportunity will help us organize our things into even deeper nestings. In this case, we have the keyword class, which defines a block, followed by our read input, which will now require a prompt. This one has not been provided as a default, so as to operate on the Z option is-elnum magic. So we do have our statement block. We also have our member function block, and we also have our class block. And all of these blocks can be considered scopes because they only come in scope as we pass through the gatekeeper, ultimately to discover that once we have a file or a folder full of files in Python, the ultimate encapsulation comes at the operating system level. Whenever we load in a file or a collection of files that we commonly refer to as a module. Once again, we won't be talking about modules, classes much until we get to Beyond the Basics or Python 2000. But you can imagine what our next challenge or activity will be. All we need to do is simply create a function, call the function, and display the results. And I would encourage you to go beyond the basics and to provide some parameters to whatever function you choose to define for yourself.